Hi, in this video, we're going to continue talking about SLAAC. We're going to look at the on-link determination, or how a device knows what network it belongs to. Okay, so how does a device know what network it belongs to? In other words, how does it know whether to send packets with the destination IP address? Can it send those directly to the device, encapsulate it in an Ethernet frame that's with an Ethernet MAC address directly for that device, or does it need to send it to the router, the default gateway? Well, IPv4, if you might remember, it looks at the compares the source and destination IP addresses. Source address, it knows what network it belongs to. It has its own IP address, IPv4 address, and it's subnet mask. So it uses that and says, I know what network I belong to. Looks at the destination IP address, uses the source's subnet mask, does the AND operation, determine what network it belongs to. If they're the same, hey, then we're on the same network. If the logical AND results in a different network address, then it says you're on a different network and I need to send the packet to the router, the default gateway. Well, IPv6 world is different. The way a device knows what network it belongs to is by the router advertisement. The router advertisement includes a prefix we see here in red, and the on-link flag, the L flag, also in red. When we see these two together, this is the router telling end devices, this is the prefix that the network, this is the prefix that the end device belongs to, with that's that L flag is set to, or is meaning. Okay. So when a host receives this, for example, our Windows host here, our WinPC, can actually do net sh interface IPv6 show site prefixes. That's a mouthful. And it will show that, yes, it learned from the router advertisement that this prefix, this is its on-link prefix. So we'll add this prefix to its prefix list. A host can belong to multiple subnets. This gets a little bit more different than IPv4. We have a lot more options in IPv6, not just for what we want to do in our networks today, but perhaps future enhancements and features. Okay, so so this tells a host, hey, any package you have with a destination IPv6 address that's a member of this network, you can send it directly to that device. Okay, so what does on-link mean? Okay, this is actually, there's no RFC on it. RFC 4861 talks in neighbor discovery for IPv6 has a section where they talk about what is meant by on-link. I won't go into a lot of details here, but I do want to mention that some of the characteristics is that, first of all, by default, a host knows that its link local address is on link. Okay, that's the only thing it knows by default, as a matter of fact. A link local address is permanently on link. Well, that makes sense, since I can reach anything. Link local means I'm only going to be reaching devices on my network. The prefix that is advertised, so here we have the prefix in red here, that's advertised in the router advertisement, is good for what's specified by the valid lifetime. So that's actually right here in the router advertisement. Okay. That tells the end device that this prefix, consider this prefix as on link for the next 30 days. And by the way, that gets refreshed every time I send you a new router advertisement with that has this prefix and the L flag set to 1. That's what that L means. So L means that the L flag has been set to 1. And it's specifically, by the way, for this prefix. Okay. So some other things. In IPv6, a device should any IPv6 address assigned to the interface, doesn't matter how, SLAAC, stateful DHCP v6, it does not matter. just because it has that address doesn't implicitly mean it's considered an on link. Yeah, that's really different. That's, although there's not a lot of uses for this right now, but a device could have an IPv6 address that is considered off link, meaning, wait a minute, I have an address that the network is someplace else. Okay, so only host can consider the prefix on link if it can be explicitly determined. Otherwise, it's considered off link. And how is it explicitly determined? Well, we had mentioned that it's done so by the router advertisement, the prefix in the router advertisement message, and the L flag set to 1. Okay, whoops, went a little faster. So packets sent to any address that are not on link are sent to the default router, the default gateway. Yeah. So again, it's the L flag set to 1 and the prefix in the RA message that tells the device, hey, this is the prefix the prefix of the link that you belong to, your local network. A little different than IPv4.